Which of the following functions is continuous over the interval negative infinity to positive infinity? Now, what we are looking for is at any point is it undefined, or at any point do I not have part of the graph? Let's take a look at the ones that I know are discontinuous. If I were to take a look at B, okay, look at the denominator. If I were to plug in 2, I would get 1 over 0 at x equals 2, which means this is going to be discontinuous at 2, so B is not an option. The graph of ln of x looks like this, because it's a log. Now, what that means is it will never, ever, 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 ever cross the y-axis here, because you're not allowed to plug in negative numbers to ln of something. So all of these negative numbers is not part of my domain, which means you are not continuous. Okay? Now, there are times where 1 over sine x becomes 0. In fact, there is an infinite amount of times. If you were to plug in 0 for x, 1 over sine 0 is 0. So not only is it discontinuous at 0, it's discontinuous at 2 pi and 4 pi and negative 2 pi and all these other spots. So D is not continuous over the entire interval. And you might be thinking, whoa, 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 whoa. How come you said that at x minus 2 you get 2? This is really no different. Oh, it sure is different. If you're trying to find what number is x squared plus 1 going to give you 0, well, you would say x squared plus 1 equals 0. You would subtract 1 from both sides and get x squared equals negative 1. When you take the square root of everything, you get x equals plus or minus square root of negative 1, which is I. I is not a real number. So there is no real number that I can plug in here and make the bottom 0, which means this can't be undefined in any places. So A is going to be my guy. Kind of tricky there. Very bizarre problem.